Hi, my name is Gabriel Katz. I'm an associate professor of politics and quantitative methods at the University of Exeter. I'm also an affiliate member of Exeter Q-Step Center. And in this video, I am going to go over some fundamental aspects of modern Bayesian computation, drawing on a previous video made by my colleague Andrei Sirnov, also from Exeter Q-Step. In particular, I'm going to start by taking a look at the nuts and bolts of modern Bayesian computation, focusing on the two most widely used Bayesian algorithms, namely the Gibbs sampler and the Metropolis Hastings. I will then review some of the criteria used to assess model convergence, namely, once I run my Bayesian model, when can I be sure that the model is ready to be used to draw inferences about parameters, say. I will then discuss some of the goodness of fit criteria which we use in the Bayesian world, which differ from those used in frequentist statistics. And I will end up by discussing methods to speed up conversion or speed up execution time. As you may know, and I'm very partial about this, the Bayesian approach, the Bayesian differential approach, has a lot of advantages. It has one big disadvantage, which is typically fitting Bayesian models in a Bayesian fashion takes a lot of time. So I'm going to review two ways in which we can reduce execution time when we estimate our models in a Bayesian fashion. First, I'm going to talk about the integration of R code and C++ code through the use of RCPP, which, as I will show you, significantly reduce the time needed to execute, to estimate a model. And then I'm going to go one step beyond that, and I'm going to talk about the integration of R and RCPP, but in the cloud, so using cloud computing. Throughout this video, and in the slides that accompany this video, there are several exercises and examples of the application of the concepts I will be discussing. You have, in the accompanying materials, you have data and codes that will allow you to practice, to reinforce the concepts, and to hopefully be in love with the Bayesian statistical paradigm.